There is a clock somewhere above you, riding through the dark on a thread of light, and it is running a little faster than the watch on your wrist, not by much. A few millionths of a second each day, no more. But it is enough to be measured, enough to matter, enough that a whole humming web of satellites must correct for it, so that a small glowing dot can find its way home across a sleeping city. High in orbit, time runs swifter. In a deep stone valley, it runs slower. In the heart of a tiny particle that crosses the whole sky in the space of a single human breath, time nearly comes to a stop. Picture too, a single thread of starlight that left its source, while great reptiles still walk the earth, arriving only now at the back of a closing eye. And underneath all of it lies one of the most tender truths science has ever uncovered. There is no single clock for the universe, no great bell that tolls the same hour for everything at once. Time is not one river. It is many rivers, countless of them, each finding its own pace. What might it feel like to live inside an hour that is yours alone? You do not need to hold any of this. There is nothing here to learn, nothing to keep, nothing that will be asked of you in the morning. Let the ideas move through you the way warm water moves over smooth stones, touching each thought for a moment and then sliding on, leaving everything a little softer than it found it. Some of these wonders will follow you down into sleep, and some will dissolve before you wake, and either way is exactly right. This is the rare comfort of a truth this large. It was true long before anyone thought to measure it, and it will go on being true whether you remember a single word of it or not. So let your shoulders come down from where the day has held them. Let the eyes close whenever they are ready. The cosmos keeps no schedule, and tonight, neither do you. Begin with something you have always believed without ever once being told. 2 clocks, set side by side, reading the very same hour down to the last fraction of a second. You expect them to agree forever, the way 2 voices that begin a song together expect to end it together, in the same breath, on the same note. And for almost the whole of human history, no one had any reason to think otherwise. A clock was a clock. An hour was an hour. The same hour everywhere. The same in a high tower as in a deep cellar. The same for a running child as for a sleeping one. The entire shape of ordinary life is built upon that assumption, and it holds so very nearly true at the speeds a human body moves that no one ever caught it quietly failing. But it is not quite true. Move one of those 2 clocks, carry it, fly it, lift it into orbit, and then bring it home again, and it will no longer read the same hour as the one that stayed behind. The difference is faint as a held breath. But it is real, and it has been seen again and again by patient hands. A young clerk in a patent office noticed the first crack in that old certainty more than a century ago, working in the evenings between other people's inventions. He spent his days in the Swiss city of Bern, reviewing drawings of mechanisms and devices, signing forms, stamping pages, and turning over, beneath all of it, the deepest questions a mind has ever held. He was not yet a professor. He had no laboratory, no grand instruments, no telescope trained on any star. He had a desk, a window, a pencil, and the long, patient evenings of an ordinary working life. His name was Albert Einstein, and in the year 1905 he set down a handful of ideas that took time apart and reassembled it into a new and stranger shape. That single year would later be called his miraculous one, for in those few months he reached so deeply into the workings of reality that the whole of physics would spend the next 100 years catching up to what he saw from that small wooden desk. He began from something almost absurdly simple, a single stubborn rule about the behaviour of light, and he followed that rule without flinching all the way to the place it led, even though the place it led overturned the very meaning of the word now. He found that a moving clock must run slow, not seem to run slow, not appear to, run slow, in genuine truth, measured against a clock that was left behind, and the faster the motion, the deeper the slowing grows. This is the first half of what came to be called relativity, and it is the reason the wristwatch on your arm and the satellite's racing clock will never quite agree, no matter how carefully they are set. The whole of it rests upon one strange fact about light. The kind of fact that feels wrong the very first time the mind is asked to hold it. The speed of light is the same for everyone. Race toward a beam of it as fast as any rocket could ever carry you, or rush away from it just as hard in the other direction, and you will still measure that light slipping past you at exactly the same speed. Not one fraction faster, not one fraction slower. Nothing else in all of nature behaves this way. A thrown ball gathers the speed of the hand that throws it. A sound gathers the speed of the wind that carries it. Walk briskly towards someone calling your name across a field, and their voice reaches you a touch faster than it otherwise would. Walk away, and it reaches you a touch slower. Everything ordinary adds and subtracts its speeds in just this common sense way, the way two rivers meeting either quicken or slow. But light keeps its own constant pace no matter who is moving, or how quickly, or in which direction. That pace is enormous beyond easy imagining. Light crosses the distance from here to the moon in scarcely more than a single second, and could circle the entire Earth more than 7 times in the time it takes to say a short sentence aloud. And whether you fly to meet it at unthinkable speed, or flee from it with all your might, that beam still passes you at exactly the same unvarying rate. And once that single fact is taken seriously, something else has to give way. If the speed of the light can never change, then the things once thought perfectly fixed, the length of a second, the measure of a shared now, those are the things that must bend instead. Time becomes the part of the world that yields. Hold that idea gently in the mind for a moment, because everything else in this long night flows out of it. If light always crosses the same distance in the same time for every single observer, then two observers who move differently simply cannot agree on how long a second lasts. The one in motion measures longer seconds. Their clock, watched from the outside, ticks more slowly, each beat stretched just enough to keep the speed of light the same for them as for everyone. The effect is impossibly small at the speed of a walk, a train, a soaring jet. You would have to travel at a real fraction of light's own velocity before a single second stretched in any way a person could ever feel in their bones. But the stretching is always there, folded silently into the arithmetic, waiting at the edge of every motion, however slow that motion may be. It does not switch on at some threshold. It is simply always present, scaling smoothly with speed, too faint to notice and too true to deny. The deeper you press toward the speed of light, the more dramatically that hidden stretching opens out into the visible. At everyday speeds, the slowing is too tiny to imagine, a millionth of nothing at all. But push a clock to half the speed of light, and it loses a noticeable little. Push it to 9/10 of light speed, and it falls clearly behind. Press it to 99%, and a single hour spent aboard might stretch to 7 full hours back home. The traveller living slow and unhurried while the whole world races ahead of them. Press on harder still, to 1,000th shy of light's full speed, and a single day for the traveller could become decades on the earth they left. Harder yet, and a brief voyage might outlast whole human lifetimes back home. The arithmetic has no ceiling. Each step closer to that ultimate speed pays out a larger and larger ransom of time, the gap between the goer and the stayer widening without any bound at all. There is no wall standing in the way, no place where the effect suddenly switches itself on. It simply grows and grows, smooth and continuous, climbing ever upward toward the unreachable. The closer a thing comes to the speed of light, the more its own time slows until at the very edge, which nothing carrying mass can ever quite touch, a single fleeting moment would seem to last forever. That is only the first kind of time bending though, the kind born purely of motion. There is a second kind, and Einstein found it a full 10 years later, after a much longer and harder climb of the mind. In the year 1915 he completed a deeper theory, one that reached past mere motion and down into gravity itself. It had taken him a full decade of struggle to build it, years of wrestling with unfamiliar mathematics, of false starts and patient revision, of a problem so hard it nearly broke him before it finally opened. He had been turning over a single peculiar thought for years on end, a thought he would later call the happiest of his entire life. It came to him, he said, while imagining a person falling freely from a rooftop. The sudden realization that, during the fall, that person would feel no weight at all, as though gravity had simply switched off. And what that thought finally told him, once he had followed it all the way to the bottom, was that gravity does not merely pull on things, the way everyone had always assumed. Gravity bends the very fabric of space and time, and in bending that fabric it slows time down. The thought that started the whole second revolution was almost childlike in its plainness. Imagine being inside a sealed room with no windows at all, and feeling your feet pressed firmly to the floor. You cannot tell from inside that room whether it rests on solid ground with gravity holding you down, or whether it sails through empty space while something far below accelerates it steadily upward, pushing the floor up against the soles of your feet. The two situations feel precisely, indistinguishably the same. Drop a coin inside that sealed room, and it falls to the floor at the very same rate whether gravity is pulling it down or the whole room is rushing upward to meet it. Hold out your arm and feel its weight pressing down. You cannot tell from any sensation inside your own body which of the two stories is the true one. There is no experiment you could ever perform within those windowless walls to distinguish a world with gravity from a world simply accelerating. Einstein realized that if they feel the same, then in some deep and fundamental way they truly are the same. That gravity and acceleration are merely two faces of a single underlying thing. And since motion already bends time, as he had shown a decade before, then gravity, being its twin, must bend time too. To sit still in a gravitational field, it turns out, is its own quiet kind of falling, and it costs you the smallest sliver of time. So the rule that emerges is this, and it is a gentle one. The deeper a clock sits within a gravitational field, the more slowly that clock runs. Down low, near a great heavy mass, close to the dense beating heart of a world, time creeps. Up high, far away from the pull, time hurries along. A clock placed at the foot of a mountain ticks slower than the same clock carried up to its summit. A clock at sea level runs slower than one lifted skyward in a drifting balloon. The difference is unimaginably small in the modest gravity of the Earth, far too faint for any human sense ever to catch. But it is there, woven into the curved shape of space and time around every massive thing in existence, and modern instruments have at last grown delicate enough to feel it directly. Gravity, it turns out, is not a force reaching across empty space. It is the shape of time itself sloping downward toward every heavy thing. Here is a consequence so faint and so strange that it can slowly rearrange how you feel inside your own resting body. Your head is very slightly older than your feet. Standing upright, the crown of your head sits a little farther from the centre of the Earth than the soles of your feet do, a little higher up out of the planet's gravity well, in a place where time runs the merest trace faster. Over the whole length of a long human life, that difference adds up to something almost unsayably tiny. A few billionths of a second, no more than that across all your years. You will never feel it. You could never measure it without the very finest instruments ever built by human hands. But it is genuinely true. Every upright person who has ever lived carries a faint gradient of time within their own body, the head racing ever so gently ahead of the feet for as long as they stand beneath the open sky. The fact sounds like nothing more than a lovely poem, until you learn that it has actually been measured, and then it becomes something far stranger and far better than any poem. Scientists have built clocks so exquisitely precise that they can detect the difference in the flow of time between two floors of a single ordinary building. Think of what that means in a house like any other, that the time at the top of the stairs and the time at the bottom are not quite the same time, that a bedroom upstairs races ever so faintly ahead of the kitchen below it, that the attic is the future of the cellar by the very thinnest margin. It is true in your own home tonight, in the small space between the floor you rest on and the ceiling above you. Carry one of these clocks up a single flight of stairs, and it will run measurably faster than its twin left behind below. Not merely in theory, not merely on a page of equations, but in the glowing readout of a real machine resting on a real bench in a real laboratory. The change is fantastically small, a fraction of a second spread thin across many years, and yet the clocks can plainly see it. The simple act of climbing a staircase lifts your body into a place where time moves at a subtly different pace, and there are now instruments steady enough to notice the difference. The clocks that can accomplish this are among the most extraordinary objects ever shaped by human hands. At a national laboratory set high in the dry desert air of Colorado, researchers built a matched pair of atomic clocks that keep time by reading a single ion of aluminum, held almost perfectly still and chilled to a hair above the very coldest temperature there can be. To understand how such a clock works, imagine an atom as a tiny bell that rings at one precise and unchanging pitch, a frequency so reliable that nature itself uses it as a tuning fork. The clock counts the shimmer of that ringing hundreds of trillions of beats every second, and from that fantastically rapid count it measures the passing of time more steadily than any swinging pendulum or coiled spring ever could. The single aluminum ion floats in a trap of electric fields, suspended in near total emptiness, untouched by any wall, shielded from every stray nudge of heat or motion. It is one of the most carefully protected objects ever made, a lone atom cradled in nothing ringing out the seconds. With these two clocks, they raised one of them just 33 centimeters above the other, about the height of a small stack of books, the rise of a single low step, and they watched the higher clock pull faintly, steadily ahead of the lower one. A third of a meter was all it took. Einstein's grand theory of gravity and time, once a thing of distant stars and imaginary falling elevators, had been brought all the way down to the scale of a tabletop and a footstool, and there it held perfectly true. With those very same clocks, the researchers reached out and touched the other kind of time-bending too, the kind born of motion rather than gravity. They set one of the trapped ions moving, sliding it back and forth at a speed no faster than a person strolling unhurried across a room, somewhere near the easy pace of a bicycle, and the moving clock fell behind its still companion, exactly as a century-old theory had insisted it must. A few meters every second was enough to make it visible. Both halves of relativity, the half about gravity and the half about speed, had now been caught operating not among the distant galaxies, but at the scale of a tabletop bench, in a motion softer than a small child wobbling along on a tricycle. The grandest ideas in physics, made small enough to hold in the palm of a single afternoon. The instruments have only grown finer in the years since. At another laboratory, physicists arranged many thousands of atoms in a thin, shimmering lattice woven of laser light, and they read the flow of time across the full height of that single small glowing cloud. A difference of about a millimeter, scarcely the thickness of a fingernail, a single millimeter. You could lay a grain of fine sand in the gap and lose it. And yet, across that whisper of a distance, the topmost atoms in the little cloud lived faster than the ones a hair's breadth below them, and the instrument read the difference plainly. There is no smaller scale at which the effect politely comes to a stop. Gravity is bending time across the width of the room where you're resting, across the height of a teacup left on a table, across the small gap between your pillow and the floor beneath your bed. The bending is simply far too gentle, almost everywhere a person ever goes to ever once be felt by the body it passes through. For the better part of a century, these effects lived only inside laboratories and equations, beautiful and remote and known to almost no one. Then, very quietly, they became a part of ordinary daily life, hidden inside a small device that rides in nearly every pocket on Earth. The system that tells a phone exactly where it stands upon the planet depends on a fleet of satellites circling high overhead, each one carrying an atomic clock, each one broadcasting the precise time without pause, day and night. To find a single position on the ground, the device listens to several of these orbiting clocks at once and carefully compares how long each separate signal took to arrive. The whole elegant method rests on timing so exact that a difference of a single millionth of a second matters enormously, and at that fine level of precision, the bending of time by speed and by gravity is no longer a distant curiosity. It becomes the difference between knowing where you are and being utterly, hopelessly lost. Those satellites live within a curious double bind of time, pulled in two directions at once. They move fast, many thousands of miles every hour, and all that motion slows their clocks, dragging them a hair behind the clocks resting on the ground far below. But they also fly very high, lifted far up out of the thickest part of the Earth's gravity, and all that height speeds their clocks up, pushing them ahead instead. Two opposite effects tugging in contrary directions, and the remarkable thing is that they do not cancel each other out. The height wins. Up where the satellites ride, the lifting of time by weaker gravity quietly outpaces the slowing of time by speed, and the clean net result is that each orbiting clock runs faster than its earthbound twin by about 38 millionths of a second every single passing day. A small number, written into the silence above the world. Take that one small number apart and it tells two separate stories at once, balanced against each other. The speed of the satellites, considered all by itself, would make their clocks lose roughly 7 millionths of a second a day, the simple toll exacted by motion. But the gentler gravity found at their great height would make those same clocks gain about 45 millionths of a second a day, the generous gift of altitude. Subtract the one figure from the other, and 38 remain, the daily margin by which orbit outruns the ground. It is a curious and lovely thing that the two great discoveries of a single mind, made 10 years apart and once thought to belong to utterly different worlds, one the physics of motion, the other the physics of gravity, should meet so plainly in the workings of a single small machine circling the Earth. Both halves of Einstein's life's work, the special theory and the general, are written together into that single tally. The slowing of speed and the quickening of height set side by side and weighed against each other in the cold and silent space above your head, every hour of every day. A few dozen millionths of a second sounds like nothing a single person could ever bring themselves to care about. But light and radio cross enormous distances in even that tiniest sliver of time, and the satellites measure position entirely by timing. Left uncorrected, that tiny daily error would not stay tiny for long. It would pile up relentlessly, throwing the calculated position off by about 10 kilometers more with each passing day. Within hours, the maps would begin to drift. Within mere days, they would become useless, sending travelers confidently toward the wrong towns, the wrong rivers, the wrong empty fields. The only reason the little dot reliably finds the right street is that the engineers built Einstein's correction directly into the clocks before they ever left the ground, deliberately tuning them to tick at a slightly wrong rate so that, once lifted up into orbit, they would run exactly right. There is something genuinely astonishing folded into that. A theory dreamed up in stillness by a single person with a pencil and a window. A theory about the deepest shape of time now hums silently inside the most ordinary errand. Every time a route appears glowing on a screen, every time a calm voice says to turn left up ahead, the answer has passed invisibly through Einstein's understanding of gravity and motion. Relativity is not only a thing of black holes and dying suns and distant galaxies. It is folded into the most mundane corners of an ordinary day, steering unseen, asking no thanks, invisible as the air in the room. The strangeness of time has become a faithful household servant, working tirelessly in the background, and almost no one who leans on it each day has ever once paused to learn its name. Long before the satellites ever flew, people found a way to catch the effect using clocks they could carry by hand. In the autumn of 1971, two scientists bought ordinary airline tickets and flew a set of atomic clocks all the way around the world aboard commercial passenger jets, once heading eastward, once heading westward, while a set of identical clocks stayed behind at the observatory. It was a wonderfully humble experiment, the future of physics riding along in a passenger seat with a tray table and a small oval window. When the travellers finally returned and the clocks were carefully compared, they no longer matched the ones that had stayed behind. Time had bent for the flyers by exactly the few billionths of a second that the equations had foretold in advance. The deepest truth of the cosmos, confirmed at cruising altitude over the clouds. The direction of each flight even made a real difference, in a way that delights the mind once it finally settles into place. The Earth itself is forever turning, carrying the ground and everything resting upon it steadily eastward through space. So a clock flown east, moving along with that great spin, travels faster overall and loses a little more time, while a clock flown west, moving against the spin, travels slower overall and loses less, or even gains a sliver. It is a delicate point, and worth holding carefully. The ground itself is not standing still. It is already moving, riding the planet's spin eastward at a fair clip. A jet heading east piles its own speed on top of that, while a jet heading west works partly against it, and the two end up moving at genuinely different speeds through the deeper frame in which all this is reckoned, and so their clocks slow by genuinely different amounts. The eastbound clock and the westbound clock therefore came home reading slightly different hours from each other, and both of them differed from the clock that had never left the ground at all. 3 travellers, 3 different amounts of elapsed time, every one of them perfectly correct. The silent spinning of the whole world had written itself, in billionths of a second, into the faces of 3 small machines. From the great and the carefully engineered, the story now narrows down to something almost too small to picture. A brief flicker of a particle, born in the high cold air far overhead. Above your sleeping head, the upper atmosphere is constantly being struck by fragments hurled outward from distant stars, high-energy particles racing in across the vast dark of the galaxy. When one of them collides with the thin air up there, it shatters into a fine spray of lesser particles, and among them is one called the muon, a heavier cousin of the humble electron that lights every wire. Muons are born some 10 or 15 kilometers up, in the bright thin cold near the very edge of space, in the crackling aftermath of those collisions, and they come hurtling straight down toward the ground at very nearly the full speed of light, a soft invisible rain. This rain has been falling, unfelt, through every roof and every forest canopy and every sleeping body, for as long as the Earth has had an atmosphere to catch the cosmos in. But the muon is a fragile and fleeting thing, here and then swiftly gone. Left entirely to itself, at rest, a muon lives for only about 2 millionths of a second before it dissolves into smaller pieces. A lifespan so brief it makes the blink of an eye seem to stretch on like an age. In that vanishingly tiny window of existence, even travelling at nearly light speed, a muon should be able to cross only a few hundred meters before winking out. Yet the journey down from the high atmosphere to the ground is far longer than that, many full kilometers down through the steadily thickening air. By every reckoning of ordinary physics, almost none of these particles should ever survive the long fall. They should vanish, mid-flight, in the upper sky, and the ground far below should be left very nearly bare of them, swept clean before they could ever arrive. And yet they arrive in their multitudes, stand at sea level, anywhere on Earth, and the muons are pouring silently through you, through the roof and the ceiling and the crown of your resting head, dozens of them passing through your open palm in every single second of every quiet night. Hold up your hand in the dark for a moment, palm open to the ceiling. In the time it takes to read this sentence, a small host of these particles has passed straight through it, through skin and bone and the empty spaces inside every atom, silent, harmless, unfelt, on their way down into the ground beneath you. They have been falling through every person who has ever lived, through cathedrals and forests and oceans, a constant gentle sleet from the edge of space that no roof has ever turned aside. They reach the ground in vast and steady numbers, far more of them than their fleeting little lives should ever allow, and the reason is precisely the slowing of time. Because the muons travel so very close to the speed of light, their inner clocks run slow as seen from the ground below. Their brief 2/millionths of a second stretch out from our earthbound vantage into time enough to complete the whole long journey. Time dilation is not a thought experiment for these tiny particles. It is the single reason they live long enough to ever touch the surface of the Earth at all. Scientists confirmed this with a beautifully direct measurement carried out on the cold side of a mountain. They counted the muons arriving up at the top of Mount Washington in New Hampshire, nearly 2 kilometers above the sea, and then they counted again at the very bottom, down near sea level. By the rules of ordinary physics, with such impossibly short lives, the great majority of those muons should have decayed away on the trip down, leaving only a faint scattered remnant to reach the base. Instead, far more of them survived the descent than should ever have been possible. The muons' tremendous speed had stretched their lifespans by exactly the amount Einstein's equations demanded. The bending of time was not merely glimpsed in some far-off observatory through a lens. It was counted directly, particle by patient particle, on a chilly New England slope. That very same story looks utterly different when seen from the muon's own point of view, and the two views fit together like a key sliding home into a lock. From where you stand on the ground, the muon's brief life is stretched long and generous, but ride along beside the muon, and its life feels as fleeting as it ever did. 2/millionths of a second, and not a moment more. From the muon's own frame, what changes instead is the distance it must cross. The entire height of the atmosphere, the whole great bulk of the mountain, the many kilometers of air below, all of it contracts, squeezed thin in the direction of the moon's motion until the journey becomes short enough to finish comfortably within a single fleeting lifetime. One observer sees stretched out time, the other sees shortened space. Both of them are completely right, and both arrive at the very same answer in the end. The muon reaches the ground. That perfect agreement is the deep and patient genius of the whole theory. It never once lets two observers truly contradict each other about anything that actually happens out in the world, about which particle struck which detector, about precisely what a clock read in the instant it flashed past. The two may disagree all they like about how much time elapsed, or about how long a given stretch of space measured out, but on the events themselves, the real meetings and partings and arrivals of things, they always, without exception, agree completely. Reality itself stays whole and seamless. All the disagreements live only inside the measuring, never inside the world, and there is a profound reassurance resting in that, a sense that beneath all the strange bending of time and space, something underneath stays honest and shared and unbroken. This is the deep soil from which the most famous riddle in all of relativity grows, the one that has come to be called the twin paradox, and it is far gentler than its forbidding name suggests. Imagine two siblings, born together on the very same day. One of them stays home upon the earth, the other boards a ship and travels far out into open space at tremendous speed, journeys for what feels to them like only a few short years, then turns the ship around and comes home again. When the traveller at last steps back down onto solid ground, they find that far more time has passed at home than ever passed aboard the ship. The one who stayed behind has aged many years. The one who flew away has aged only a little. They were born on the same morning, and now they are no longer the same age at all. The traveller has come home young. The puzzle nested inside it is this: if all motion is relative, if each twin could equally well claim that it was the other one who was truly moving, then why does only one of them end up younger than the other? And the answer is every bit as elegant as the riddle itself. The two situations are not, in the end, mirror images of each other. The twin who stays home rides a single, smooth, unbroken motion straight through time, but the travelling twin must speed up, then slow down, then turn fully around and come back, must feel the firm push of acceleration in their very bones, must change direction in a way the stay-at-home twin never once does. Only one of them can point to a moment when the whole universe seemed to lurch around them, the moment of turning, when the engines fired and the stars wheeled and the body was pressed back into its seat. The stay-at-home twin never felt any such thing. The world held steady around them the entire while. That difference is real, and it is felt, and it breaks the perfect mirror between the two. It is precisely that turning, that single break in the otherwise smooth path, that settles the entire matter. The twin who took the longer, bent, harder road through space and time is the one who aged the less. There is no contradiction hiding anywhere within it. There is only the quiet truth that different paths through time can carry different lengths, and this is not merely a tidy fable invented to teach a lesson. It has genuinely happened to real living people, to actual twins. There are two brothers, born just minutes apart, who both grew up to become astronauts. Scott and Mark Kelly, identical in their genes and in their faces down to the smallest detail. Being true identical twins, they offered scientists a rare and precious thing. Two human bodies that began as nearly the same as two bodies can ever be, one of which would go to space while the other stayed home. Researchers studied everything about them, the blood and the bones and the very structure of their cells, hoping to learn what a long stay in orbit does to a person. And folded into that great study was this smaller, stranger gift, a living test of Einstein's century-old riddle, carried out not with clocks alone, but with two beating hearts. One of them, Scott, spent very nearly a full year aboard a station endlessly circling the Earth, watching the blue curve of the world slide past his window again and again, while his brother Mark stayed quietly home on the ground below, walking on that same blue world, aging at the ordinary earthbound rate. They were precisely the same age when the long mission began. They were not quite the same age when it finally ended. Racing around the whole planet for almost a year, Scott aged the smallest measurable sliver less than his earthbound twin. The twin paradox made flesh and bone, lived out in full by two ordinary men who could simply call each other on the telephone about it afterward and marvel together. The amount of it is so small that it borders on the tender. Across that entire long year spent up in orbit, Scott Kelly came home younger than his brother by only about 5,000ths of a single second. 5 milliseconds, less time than it takes to blink an eye, spread thin across a whole year of sunrises seen 16 times a day from above the clouds. He did not step down off the craft looking visibly younger. No one alive could ever see such a vanishing thing with their own eyes. But the clocks could see it plainly, and the equations had named the precise figure well in advance. Somewhere inside those two nearly identical lives, 5,000ths of a second now separate two men who began upon the very same bright morning, a small difference earned by speed alone and carried home as a gift. Others have gathered far more of this strange and invisible youth across the spans of their lives. One cosmonaut, a patient man named Sergei Krikalev, spent more than 800 days of his life aboard orbiting stations across many long missions. More accumulated time in fast flight than any other human being who has yet lived upon the Earth. Adding it all carefully together, the slowing of his clock against the steady clocks back home comes to roughly 200ths of a second. Picture all those days gathered up. More than 2 years of a single life spent racing around the Earth at a speed that circles the whole planet in an hour and a half. And the strange dividend they paid, a 50th of a second of borrowed youth. The cosmos setting his clock back by that tiny amount in return for all his miles. He has, in the most literal and measurable sense that the universe allows, travelled the very farthest into his own future of anyone now alive, arriving back down on the ground a small fraction of an instant younger than he otherwise ever would have been. He holds a quiet record that no one can ever see with the eye. He is the human being most softly unstuck in time. The station that those travellers rode through the sky moves astonishingly fast, about 17,000 miles in a single hour, fast enough to circle the entire planet in roughly 90 minutes, fast enough to chase a fresh sunrise 16 separate times between one earthbound sleep and the next. It is that tremendous speed that slows the astronauts' clocks, and though the station also rides somewhat higher than the ground, up where the weaker gravity would tend to speed time up, At the station's particular altitude, the speed wins the contest. The slowing from sheer motion outweighs the lifting from height, and so the crew, on balance, ages a faint touch more slowly than the rest of us turning steadily below. They return down from the sky having spent a little less time than they ever would have spent had they simply stayed at home. Lift higher still though, and the delicate balance tips the other way entirely. The satellites that carry the navigation clocks orbit far, far above the station, many thousands of miles up, where the grip of the Earth's gravity is thinned out considerably. Up there, the generous gift of altitude overwhelms the modest toll of speed, and those high clocks run faster than the ground rather than slower. So whether any orbiting clock runs fast or slow depends entirely upon how high it happens to fly. Low and quick, like the crewed station, and time runs slow, high and far like the navigation fleet, and time runs fast. The same planet beneath them, the same unbending physics governing them both, and yet two precisely opposite outcomes, decided in full by nothing more than altitude. Height alone tips the scales. Somewhere between those two heights, there must lie a single point of perfect balance. One special orbit where the two competing effects cancel each other out exactly. Below that height, a satellite moves quickly and sits relatively low, so the slowing of speed has the upper hand and its clock runs behind the ground. Above that height, the satellite moves more slowly and sits much higher, so the lifting of altitude wins and its clock runs ahead. Right at the crossover, the two influences meet as perfect equals. At a certain altitude, roughly 3,000 kilometers above the surface, the slowing from a satellite's speed precisely matches the speeding from its height, and a clock placed carefully there would tick at the very same rate as a clock resting on the ground far below. It is a kind of still point woven into the bending of time, a faint invisible seam in the sky where orbit and Earth keep exactly the same hour. Above that shell, clocks gain time, below it, clocks lose time, and along that one unseen surface suspended in the dark, the two great effects of relativity reach out and hold hands and agree, for a moment, on what the hour truly is. Now let the imagination travel far beyond any satellite, out to where gravity grows so fierce that time itself nearly comes to a standstill. Around the most extreme objects in all the cosmos, collapsed stars so impossibly dense that their gravity bends everything near them, the slowing of time becomes not a faint sliver, but a vast and yawning ocean. Approach such an object, and your own clock would crawl, more and more slowly against the steady clocks of all the distant stars. The deeper you fell into that gravity, the further behind your time would lag the time of the wider universe around you. What is merely a fraction of a heartbeat near the gentle Earth becomes, near these crushing objects, an enormous gulf. Long hours measured against brief minutes, whole years measured against single days, the calm, familiar arithmetic of relativity stretched all the way to its grandest imaginable scale. Around such an object there lies an invisible boundary, a sheer threshold drawn in empty space, and something remarkable happens to time as it nears that edge. Imagine watching a friend drift slowly toward that edge, a lantern in their hand, while you wait at a safe distance and observe. At first they fall as anyone falls, but as they near the threshold, something strange creeps into the picture. Their motion seems to thicken, as though they were sinking into honey rather than empty space. Their lantern, swinging once a second, begins to swing more slowly to your eye, once every 2 seconds, then every 10, then every hour. To a watcher safely far away, a clock falling slowly toward that boundary appears to slow, and slow, and slow, still further, its ticks stretching farther and farther apart, until at the edge itself the clock seems to freeze altogether, hanging there motionless forever, just outside. The lantern's light grows dimmer and redder with each stretched moment, sliding down through orange and deep crimson toward a darkness no eye can follow, until at last it fades from view entirely, not because your friend has fallen in, but because to you they never quite seem to arrive. an image held perfectly still at the threshold, like a single frame paused and held at the very end of a long reel of film. And yet, and this is the part that lifts the whole strangeness up into something like beauty, for the one who is actually doing the falling, nothing feels frozen in the slightest. Their own clock ticks steadily along at its usual familiar pace, second after ordinary second. They do not feel time stop. To them, the crossing of that distant-looking threshold is an unremarkable thing, a quiet passage with no fanfare at all, their watch ticking calmly the whole way down. Two utterly different stories told of the very same fall. One watcher sees time freeze and hold forever, while the traveller within feels it flow on as evenly as it ever has. Neither of the two is wrong. Time near such an object is simply far too rich and far too deeply bent to ever be told in only a single tale. The light itself carries the message of all this bending outward into the universe, and it does so by changing its colour. When light climbs up and out of a strong gravitational field, escaping from down low toward the watchers far above, it loses a little of its energy along the way, and to lose energy is to grow redder. Astronomers call this the gravitational redshift, and it is the visible fingerprint of slowed time written across the sky. A beam that begins as crisp, clean blue down near a heavy mass arrives, far away, leaning toward the warm, fire-glow end of the colours, reddened by the long, hard climb up out of the well. The deeper the well it climbs from, the redder still it grows. Colour itself becomes a way of reading, from a great distance, how strongly time was being bent down below. This reddening of climbing light was caught right here on Earth, inside a single tall room, with great patience and greater care. In 1959, physicists at Harvard sent a beam of light from the bottom of a tower up to the top, a rise of just over 20 metres, the height of a few ordinary stories, no taller than a modest building you might pass without a second glance, and they measured at the summit that the light had reddened by the very faintest imaginable amount on its way up. To catch a shift so vanishingly small, they used one of the most exquisite tricks ever devised, a way of reading the colour of light through the trembling of atomic nuclei themselves, sensitive enough to notice a shift in pitch finer than almost anything ever measured before. They even carefully warmed and cooled their instruments, and moved them up and down, teasing the tiny effect out from the noise with extraordinary patience. The whole experiment was a triumph of care over scale, an effect so faint that the universe itself seemed to be whispering, caught and confirmed inside a single ordinary stairwell. The change was almost nothing at all, a few parts in 1,000 million. But it was exactly the change predicted by the bending of time across that small height. A simple beam of light, climbing a single tower in a single building, had carried within its faint colour the clear proof that time runs slower near the ground than near the ceiling. Even our own sun bends time enough to subtly colour its own light. Down at the blazing surface of the sun, where gravity pulls far harder than anything we know on Earth, time runs measurably slower than it does out here in the thin, quiet reaches of space. And so, the light the sun pours toward us arrives very slightly reddened, having climbed, as it must, up out of the sun's own deep gravity well before crossing the great void to reach a waiting eye or instrument. The effect is small, but astronomers can measure it directly in the precise colours of sunlight, reading in those tiny telltale shifts the slowing of time at the very surface of a star. Every dawn that ever warmed the skin of your face arrived a faint shade redder than it began, for having climbed up and out of the sun's own slowed and weighted hour. That same deep well of the sun reaches out and touches the pace of your own hours, and it does so a little differently with each turning season. The Earth does not circle the sun in a perfect ring, but in a gentle oval, drawing a touch nearer in the heart of one season, and a touch farther away half a year later, and as it nears the sun it also quickens, sweeping along a little faster through space. Both of those changes bend the local flow of time by the faintest trace. When the Earth swings closest to the sun, sunk a little deeper into that great gravity well, and rushing a little faster along its path, every clock upon the whole planet runs the merest sliver slower than it does at the far point of the orbit, where the world drifts wide and unhurried in the cooler dark. The difference across the year is almost nothing, a few billionths against the steadiest reckoning there is, but it is genuinely there, a slow yearly breathing of time woven into the shape of our long fall around the sun. The entire Earth, carrying everyone upon it, speeds its hours a feather's weight and then eases them again, once around with every passing year, riding the gentle in and out of its own quiet orbit. Far stranger and far stronger still is the bending of time at the very heart of our own galaxy, where a truly colossal mass holds silent court in the dark. Astronomers have watched individual stars sweeping along tight, swift orbits around that central region, and they have carefully tracked one star in particular as it swung in close and then raced back out again. For years, with the largest telescopes on Earth, astronomers traced that one star along its long looping path, a single point of light, swinging in toward the centre and then flung back out, taking a human lifetime to complete one circuit. At its closest approach, it whipped past the central mass at a staggering speed, skimming the edge of the deepest gravity well in the galaxy, and in that moment its light carried the unmistakable mark of bent time. As that single star reached its nearest pass, deep down in the powerful gravity, its light reddened in precisely the way relativity demands. The gravitational shift seen not in a laboratory tower, but across some 26,000 light-years of empty space, in the real motion of a real star around the dark and heavy heart of the Milky Way. Even there, at the wild and crowded centre of everything, deep in the strongest gravity for tens of thousands of light-years in any direction, time keeps faithfully to Einstein's gentle and unbreakable rule. Sometimes the bending of space-time does not merely colour the passing light, but sends ripples spreading outward through it all, like the surface of a still pond after a tossed stone. When two of those collapsed massive objects spiral together and finally merge, they shake the woven cloth of space-time itself, sending out waves that travel across the whole universe at the speed of light, stretching and squeezing everything they pass through by an amount almost too small to imagine holding in the mind. The instruments built to catch them are among the largest and most delicate machines humanity has ever made. Long arms of laser light, kilometres in length, stretched across the landscape and tuned to notice if their length should change by an amount smaller than the tiniest fraction of the width of a proton. For years they listened to the silence, hearing nothing but the faint background tremble of the world. And then, one day, a ripple passed through, a rising tone, a chirp lasting a fraction of a second, the recorded sound of two distant massive objects spiralling together and merging into one. In recent years, exquisitely sensitive instruments built on Earth have actually felt those waves arrive. A tremor running through space-time smaller than the width of a single atomic nucleus, the faint and distant echo of a tremendous collision that happened more than 1 billion years ago. Two great masses had circled each other, drawn ever closer, and joined in a single soundless flash of bent space-time, while the Earth was still young and lifeless, and the ripple of that ancient meeting only now washed gently over a quiet instrument waiting in the dark. Space-time is not a fixed and silent stage on which things merely happen. It can ripple. It can ring softly, like a struck bell. Out in that same vast dark, nature keeps some of the most faithful clocks to be found anywhere in all the cosmos. When certain massive stars finally collapse, they leave behind a tiny, impossibly dense core that spins rapidly and sweeps a narrow beam of radio light around and around like the lamp of a lighthouse. The very first one discovered sent astronomers a pulse so impossibly regular that, for a brief while, they half wondered whether it might be a signal from another civilization, some far beacon ticking out a message across the void. It was not. It was something stranger and more wonderful still. A city's worth of mass crushed into a sphere the size of a small town, spinning many times each second, its lighthouse beams sweeping past the Earth with the patience of a metronome that never tires. from the distant Earth, that sweeping beam arrives as a steady repeating pulse, flashing past with a regularity that can rival the very finest clocks ever built by human hands, some of them flickering hundreds of times every second, year after year after year, with a precision that takes the breath away. So steady is their beat that astronomers can predict the arrival of a single pulse, years in advance, to within a tiny fraction of a second. A dead star, far out in the dark, keeping better time than almost anything on Earth. These are the pulsars, the natural timekeepers of the galaxy, and their reliable, faithful rhythm has let astronomers measure the gentle bending of time and space across distances no laboratory on Earth could ever hope to span. A bound pair of these stellar clocks, two of them circling each other, once gave humanity one of its very first proofs that space-time itself can carry energy away in waves. Two dense remnants, locked in a tight and swift embrace, were tracked patiently across many years and decades, and their shared orbit was seen to be slowly, steadily shrinking, drawing closer together, circling a little faster with each passing year, exactly as it must if the whole system were shedding its energy outward into ripples of space-time. The change was minute. A small fraction of a second of timing drift accumulated across long years of careful watching, but it matched the prediction with an extraordinary and humbling fidelity. Two distant stars dancing ever closer in the dark confirmed that the universe itself can ring with the silent music of bending time. The bending of time even leaves its faint mark upon how the most distant cosmic events appear to unfold, across spans so vast they reach back nearly toward the beginning of all things. When astronomers watch the brilliant explosions of certain faraway dying stars, billions of light years off in the dark, they notice something curious. Those distant explosions seem to play out in slow motion, rising and then fading more gradually than identical explosions close at hand. The reason is the steady expansion of the universe itself, which stretches not only the light arriving from those distant fires, but also the very tempo of their unfolding. These particular dying stars are precious to astronomers, for they explode with such a reliable brightness that they serve as measuring marks scattered across the deep cosmos, beacons of known strength by which the vast distances can be read. And every one of them, when far enough away, is seen to flare and fade in slow motion, its whole brief life as a brilliant beacon drawn out longer than it truly was, by exactly the amount the expansion of space predicts. The farther back into the depths you choose to look, the more stretched out the time itself appears to become. Distance in this strange and generous universe is also a kind of slowing. That stretching of distant time is woven inseparably into the deepest fact of all cosmic light. To look far away across space is always to look back into the past. The light from a star 1,000 light years off left it fully 1,000 years ago, and so you see that star not as it is tonight, but only as it once was. Gaze upon a distant galaxy, and you are witnessing an ancient event, its gathered light only now completing a long journey that began before there were any eyes anywhere to receive it. The night sky is not a single snapshot of the present moment. It is a vast and layered archive, each separate point of light arriving from its own particular moment in the long history of things, the near ones recent, the far ones unthinkably old, all of them gathered together into one single apparent instant upon the dark. All of this rests, in the end, upon the most quietly radical idea in the whole of the theory, the idea that there is no single universal now at all. We feel, deep down in the body, that this present moment must surely be spreading out across the entire universe all at once, the very same instant unfolding everywhere, a single shared hour ticking faithfully for every star and every stone alike. It seems so obvious as to need no saying, that right now, this very instant, something is happening on a world circling a distant star, and that our now and its now are the same now, joined across the dark. But relativity tells us plainly that this is simply not so. The very question, what is happening there right now, turns out to have no single answer at all. Ask it while standing still, and you get one answer. Ask it again while walking slowly across the room, and the answer shifts, the distant now sliding forward or backward by years. The word seems solid as stone beneath the feet, and yet it dissolves the moment you reach for it across any great distance. Two observers who move differently will not even agree on which distant events happen at the same time as each other. What is perfectly simultaneous for the one is not at all simultaneous for the other. The grand cosmic, now that the human mind so badly wants to believe in, simply does not exist anywhere. There is only here, and your own quiet present, and the long, patient delay of light slowly bringing all the rest of it to you. Picture it as gently as you possibly can. Two distant flashes of light, set far apart from one another in the dark. To one observer, drifting calmly along at a certain steady speed, the two flashes happen at precisely the same instant together. But to another observer, one who moves differently through the same space, one flash clearly and plainly happens before the other. And neither of the two of them is mistaken. Their clocks and their measurements are each perfectly correct in every way. It helps to see why. Light from each flash needs time to travel, and the two observers are moving differently through that travelling light, meeting one beam a touch sooner and the other a touch later. And so, quite honestly and correctly, they disagree about which flash came first. There is no trick being played, no illusion to see past. The order of the two distant flashes is genuinely different for the two of them, and there is no higher court, no master clock floating above it all to declare which of them is truly right. Simultaneity, the very idea of two separate things happening at once, turns out not to be a fact about the universe at all, but a fact about the observer. Whether two events truly share a single moment depends entirely on who is asking, and on how they happen to be moving. The simple word now turns out to be a far smaller, far more personal thing than it ever once felt. Some who think long and deeply about these matters find a strange and lasting peace in one particular way of picturing it all. If now is not universal, if the past and the future are simply directions through a great four-dimensional landscape rather than a single moving knife edge sweeping forward, then perhaps all of the moments exist together, laid out like the full length of a great river seen at once from high above. Every instant that ever was or ever will be, all of them present together within the deeper geometry, your first morning and your final evening, and this very breath you are drawing right now, each one a place in the landscape rather than a fleeting flicker that comes and then goes. It is only one way of reading the equations, a philosopher's calm interpretation, nothing more. But there is real comfort resting within it, a quiet sense that no moment is ever truly lost, only left behind, still resting somewhere within the deep unchanging shape of things. There is a precise name for the time a single traveller actually experiences, the genuine time that their own wristwatch faithfully keeps along their own particular path, and that name is proper time. Think of two roads between the same two towns, one straight and level, the other winding up and over a high pass and down again. Both begin in the same place and end in the same place, yet one is far longer than the other, and a traveller walking each would arrive having covered a different distance. Proper time is like the length of such a road, only measured in hours rather than miles. The time you actually live is the length of your own particular path through space and time, and different paths between the same two moments can simply have different lengths. Every journey through the universe, every single line traced through space and through the steadily passing hours, carries its own proper time, its own honest, private count of the seconds truly lived. Two travellers can leave from the very same place and arrive together at the very same place, having taken two different routes between, and find that their proper times no longer agree. There is no contradiction anywhere in this, only the simple and lovely truth that the duration of a journey belongs to the path itself, not to the cosmos as a whole. Your own life keeps its own proper time, measured faithfully along the single road you alone actually travel through the world. And here a small marvel lies hidden, almost the precise reverse of what the intuition expects. Among all the countless possible paths between 2 points in space and time, the one path that ages the very most is the one that simply drifts freely, that coasts along, pushed and pulled by nothing at all, falling naturally along the smooth grain of space-time itself. Any path that twists or strains or accelerates or fights against the current ages less than that. To take the smooth, unforced road, the gentle path of least resistance through the deep fabric of things, is to gather up the very greatest share of time. The traveller who strains and turns and burns their engines hard comes home the younger. The one who simply lets the universe carry them along lives at the most seconds of all. It runs against the grain of what we tend to expect, where effort earns the greater reward, but here it is rest and yielding, and the unforced path that gathers the longest measure of time. There is a softer lesson tucked away inside the cold mathematics, if you should care to reach in and find it, that there are journeys where the most is gained not by pushing harder, but by letting go, and drifting, and trusting the shape of things to carry you where it will. Beneath all the disagreement about time and about space, the theory holds one single thing perfectly steady, one shared measure that every observer agrees upon completely, no matter how they move. It blends space and time together into a single quantity, called the space-time interval, and while one observer's seconds differ from another's, and while one observer's meters differ too, this deeper combined measure comes out exactly identical for every one of them. There is a deep comfort in knowing it is there. For all the dizzying talk of clocks that disagree and nows that scatter and distances that shrink, the universe is not, in the end, a place of pure disagreement where nothing can be pinned down. Underneath it all lies something firm and shared, a measure that every observer in every state of motion will calculate and find exactly the same. It is the solid bedrock lying beneath all the shifting sand, the one quantity that all the bending in the world leaves entirely untouched. Beneath the personal hours and the personal distances, there is a single shared and unchanging truth that binds every separate point of view together into one. The universe gives each observer their own private time, freely, but it keeps one deep secret measure exactly the same for all. Light itself sits at a curious and lonely extreme in all of this, a place no clock could ever quite follow. Because time slows more and more as a thing approaches the speed of light, and because light always moves at exactly that speed, light in a real sense experiences no passage of time at all. A beam of light that sets out from a distant star and crosses millions of years of open space arrives, by its own strange reckoning, in no time whatsoever, emitted and absorbed in the very same timeless instant, the whole long voyage collapsed down to nothing. For light, there is no waiting, no journey, no before and no after. It touches its beginning and its ending all at once together. The very oldest light in the entire universe is, from its own silent point of view, brand new and freshly born this instant. And the gentlest possible counterpart to that blazing extreme is the very simplest motion of all, to stay still, or very nearly still, far away from any heavy mass. Among a set of travellers who part ways and then later meet again, the one who moved the least, who rested quietly while all the others raced and turned and strained, is the one who has aged the most. Stillness, in the strange and patient accounting of relativity, is the most generous path of all. The one who stayed home in the twin story did not miss out on time at all. They gathered the very largest share of it. To rest, to remain, to let the others rush past and away. That is, in the deepest sense the universe will ever allow, to live the longest of all. There is truly something worth carrying down with you into sleep in that. The slowing of time by speed has been pushed to wild and dizzying extremes inside great machines built to study the very smallest things. In huge rings buried deep underground, vast circular tunnels wider across than a town and lined with powerful magnets, physicists accelerate those same fleeting muons to within a hair's breadth of the speed of light, and they send them racing endlessly around in circles, lap after lap after lap, millions of times over in the blink of an eye. At rest, a muon lives only 2/millionths of a second, but whirling around that great ring at such tremendous speed, its little life stretches out by a factor of 30 or more, so that it survives far, far longer than it ever possibly could while standing still. The physicists do not have to take this on faith or read it from a chalkboard. They watch it happen, counting the muons as they circle, seeing with their own instruments how many more loops the particles complete than any stopwatch unacquainted with relativity would ever allow. The stretching of time is, in those tunnels, as plain and as countable as laps around a track. The particles live longer simply because they move faster, their inner clocks slow deeply by their own breathtaking velocity, and the great machines measure this lengthening of life with plain everyday precision. Time dilation is not some rare and exotic event in such places. It is the ordinary daily weather of the very, very fast. Some particles arriving from the deepest reaches of space move so impossibly close to light speed that the whole vast galaxy, from their own point of view, shrinks down to a crossing of mere moments. The very highest energy cosmic particles, flung violently outward by tremendous events among distant stars, travel so near the ultimate speed that their inner clocks crawl almost to a complete standstill. A journey that takes ordinary light tens of thousands of years to make, all the way across the broad bright disk of the Milky Way, would pass for such a particle in what feels to it like the very briefest flicker, its own time so deeply slowed that the entire enormous galaxy slips past in something like a single heartbeat. The faster a thing travels through space, the more softly its own clock turns within it, until at the very edge of possibility, a whole galaxy becomes nothing more than a single quiet step. That edge, though, can never quite be reached by anything at all that carries mass, and there is a deep and quiet kindness hidden away inside the impossibility. As any massive object speeds up toward the velocity of light, the slowing of its own time grows without any limit, and the energy needed to push it even a little faster grows without limit too, climbing toward the infinite. To actually reach light speed, a thing with mass would need an endless infinity of energy, and would see its own time slow all the way to a complete and final stop, and the universe simply does not ever permit such a thing to happen. So the speed of light stands forever as an unbreakable ceiling, a velocity that matter may approach for all eternity but can never once touch. The cosmos has a gentle speed limit woven into its very deepest structure, and it keeps everything that carries mass safely and forever on this near side of timelessness. Within that great limit there hides perhaps the single most beautiful idea in all of relativity, an idea that braids together motion and time into one seamless thing. Picture it like a compass needle that always points with the same full length, but can swing to face different directions. Everything in the universe, it gently turns out, is always moving through space-time at one single fixed speed, the speed of light itself, but that constant motion is forever shared out between travel through space and travel through time. Turn the needle wholly toward the time direction, and you move purely through time, racing into tomorrow while standing perfectly still in space. Tip it over toward the space direction, and you begin to trade away some of your headlong rush into the future for motion across the world instead. Light itself has tipped its needle all the way over, spending the whole of its motion on crossing space, leaving nothing at all for the passage of time, which is exactly why, for light, no time passes at all. And you, resting here, have tipped your needle almost wholly the other way, moving so slowly through space that nearly all your motion pours straight into time, carrying you smoothly and steadily forward into the night. Sit perfectly still, unmoving, and the whole of your motion is through time alone. You race straight into the future at the very fullest possible rate. But begin to move through space, even a little, and some of that motion must be borrowed away from your passage through time, and so your clock slows down to compensate. The faster you go through space, the slower you go through time, because the grand total always remains exactly the same. To move through the world is simply always, to trade one kind of journey for the other. That same exquisite sensitivity to height has begun, in recent years, to turn clocks themselves into a wholly new kind of instrument for reading the very shape of the Earth. Because an atomic clock now runs measurably faster the higher up it sits, carefully comparing two distant clocks against each other can reveal the difference in their elevation to within just a few centimetres, without any ruler at all, any survey, any clear line of sight stretched between them. The flow of time becomes, itself, a precise measure of height. For thousands of years, people measured the heights of the land with cords and rods and sight lines, carrying their reckoning step by step across the country from the distant sea. A long chain of careful measurements stretched over the hills. Now a clock can do it from where it stands, with no chain at all. Two clocks compared can tell which one is higher and by how much, reading the elevation straight from the differing flow of time between them. Scientists have given this lovely idea a name: relativistic geodesy. It means that a clock can sense whether it sits down in a valley or up on a rise, simply by feeling how fast its own seconds happen to pass. Time itself becomes a way of feeling out the gentle curves and hollows of the land. In time, this may quietly reshape the whole way the world maps its own surface. A great network of these clocks scattered across the continents and forever compared against one another could trace out the true shape of the entire planet. The long, slow swell of mountain ranges, the deep sag of broad basins, the patient rise and fall of the ground underfoot, all of it read directly from the differing pace of time at each separate point. The old familiar idea of sea level, that single smooth reference surface imagined wrapping the whole globe, could one day be defined not by tides and long averages, but simply by where the clocks all tick in perfect unison. The land would be measured by its own hours. A mountain would become, quite literally, a place where time happens to run a little faster than elsewhere. For a clock set high on a mountaintop genuinely does outrun a clock left, waiting in the valley far below, and the difference between them, though tiny, is real and lasting and true. Lift a clock from the deep stony floor of a gorge all the way up to the windswept crest of a high peak, and it will tick ever so slightly faster up in the thin cold air, gaining a small sliver of time over its lowland twin for as long as it remains aloft. Mountaineers, in the most literal and unmeasurable sense imaginable, age a faint fraction faster than the people resting in the towns far below, not nearly enough to ever notice, not nearly enough to fill even a single second across a whole long lifetime, but just enough that the equations insist upon it. Height is a small and faithful fountain of time. The high places run a little ahead of the low ones always. Take that very idea to its earthly extreme, and the numbers, though minuscule beyond imagining, become almost touching in their smallness. A clock placed at the icy summit of the highest mountain on the earth, far above the distant sea, runs faster than a clock resting at the lowest dry point on the whole planet's surface, the deep salt shore of an inland sea lying well below the level of the ocean. The difference in their two elevations is only some 9 kilometers of height, and the resulting difference in their flow of time is unimaginably, almost unsayably small, and yet across the long ages it would slowly, faithfully, patiently accumulate. The roof of the world and the floor of the world keep slightly different hours, the high cold peak always running a hair ahead of the low warm shore, two simple clocks upon one single planet, quietly and forever disagreeing. And here a deeper harmony hides beneath all that disagreement, gentle enough to soothe the very thought of it. Set one clock down at the equator and another at the frozen pole, both of them right at the level of the sea, and the two will tick at exactly the same rate, year upon year, without drifting apart by even the smallest sliver. It seems it ought not to be so. The Earth is not a perfect ball, but bulges gently at its middle, swollen by its own long spinning, so the clock at the equator sits some kilometers farther out from the planet's heavy center, up where weaker gravity would hurry it ahead. Yet that same equatorial clock is also swept along faster by the turning of the world, racing in a far wider daily circle than the nearly motionless pole, and that greater speed drags its time back down by the slowing of motion. The lift of the bulge and the drag of the spin, two effects with no reason at all to match, fall into step and cancel almost perfectly, and so every clock anywhere along the calm surface of the sea, equator or pole or any quiet shore between, keeps faithfully the very same hour. The whole rolling sea level skin of the planet turns out to be a single shared moment, one smooth surface where all the clocks of the world agree. Carry that same logic inward now, down through the rock and the metal toward the planet's own hidden heart, and time grows slower the deeper down you go. The very centre of the Earth sits at the lowest point of the planet's entire gravity well, deeper than any valley or trench could ever reach, and so time runs more slowly there than at the bright surface we walk upon. The difference has been gently estimated by those who study such things. Over the whole long life of the Earth, more than 4 billion patient years, the iron core has aged something like 2.5 years less than the crust above it. Stop and weigh that against its scale. Across an immensity of time so vast it dwarfs every empire and every species and every ice age the planet has ever known. 4,500 million years, the great accumulated difference is only a couple of years. The heart of the world is younger than its surface, by only a couple of years after all those billions. It is a measure both of how real the bending of time is and of how exquisitely gentle. Strong enough to be true, faint enough that a planet's whole molten history barely gathers 2 birthdays of difference between its skin and its core. Beneath your resting feet, down in the deep hidden core, time has been running just a touch behind, faithfully, ever since the planet first formed from dust. All the long history of the world has unfolded across that faint divide. The drifting of the continents, the rising and grinding down of mountain ranges, the coming and going of whole ages of ice, while the core kept its own fractionally slow account, a hidden clock at the centre of everything, ticking a hair behind the ground we stand upon. Carry that same truth into the sun, and it is written there far more strongly. At the sun's blazing core, where the gravity grows so intense, time creeps along more slowly than it does up at the bright churning surface, and slower still than out here where the earth quietly turns. Deep within that fusion-lit heart, where the sun's vast energy is endlessly born, the hours pass at a different rate than they do up in the cool dark between the worlds. Every star that shines is a place where time bends within itself, the centre always lagging a touch behind the surface always lagging behind the surrounding open space. A star is not only a great furnace of pouring light, it is also a landscape of time, sloping quietly downward toward a slowed and hidden core, a gradient of hours buried in fire. When a star collapses down into something small and dense, the bending of time at its surface grows from the faintest whisper into a clear and measurable voice. There is a faint companion star, the small dim partner of the very brightest star in the whole night sky, that has burned all the way down to a cinder no larger across than the earth, yet weighing nearly as much as the entire sun. That bright primary star is the one the old sailors steered by, the most brilliant point in all the night sky, a familiar blue-white jewel low in the winter dark. Few who admire it ever think of its tiny hidden companion, a faint ember circling it once every half-century or so, invisible to the unaided eye. Yet that small dim partner is one of the densest things a person can point to in the heavens. On the surface of that crushed little star, gravity is so fierce that its light is noticeably reddened by the slowing of time, leaning far toward the warm end of the rainbow, far, far more than the sun's own light ever is. Astronomers can read that telltale shift directly, in the starlight. A teaspoon of its matter would weigh as much as a small truck, and the time that passes on its surface runs slower than the time that passes on ours. A difference written openly in the colour of a star that has been hanging quietly beside the brightest light in the sky all along. A neutron star is what remains when a great star, far larger than the sun, finally exhausts its fuel and collapses in upon its own core in a single catastrophic instant. The outer layers blow away in a brilliant flare that can briefly outshine an entire galaxy, and what is left behind is the crushed heart of the star, a sphere perhaps only the size of a city, holding more mass than the whole sun pressed into that tiny ball. Denser still are these collapsed stellar cores that we call neutron stars, where matter has been packed together so impossibly tightly that a single sugar cube's worth of the stuff would weigh as much as an entire mountain range. To gather a sense of it, imagine taking the whole of the sun. 1 million Earths could fit inside it, and squeezing every part of that vast furnace inward until it would rest within the span of a small town, its gravity at the surface grown billions of times fiercer than anything we know. At the surface of such a star, the gravity is so utterly overwhelming that time runs dramatically slower there than it does out in open space. Not by mere millionths of a second now, but by a substantial and sizable fraction. A clock somehow resting on the surface of a neutron star would tick visibly, plainly slower than a clock held far away, its seconds stretched long and heavy by the crushing gravity beneath it. On such a surface, time might run perhaps a quarter or a third slower than it does in open space, a gap so large it could almost be felt. Stand there, if anything ever could, and a year of your life would pass while rather more than a year slipped by among the distant stars, the cosmos racing softly ahead of you, all because of the colossal mass pressed into the ground beneath your feet. These are among the very strongest gravitational fields anywhere in the universe, short of a true horizon, and on their surfaces time bends toward a deep and clearly measurable slowness, woven into the very fabric of the space around them. Closer to home, a gentle new fact is just now being woven into the way that people will keep their time on other worlds. On the moon, where gravity is far weaker than it is here on the Earth, time runs slightly faster than it does down here, by a little under 60 millionths of a second across each passing day. It is a tiny figure, but it is not nothing, and it grows clearer the more one leans on it. Imagine the coming years, when more than one nation hopes to set up camps and outposts upon the lunar surface, when landers must touch down within a few meters of their targets, and crews must coordinate their every action with mission controllers 250,000 miles away. All of that depends on clocks that agree, and the moon's clocks left alone do not agree with Earth's. They run faintly ahead, day after day. As people return to the moon to stay and to build, this small difference matters enough that scientists are now carefully working out a dedicated lunar time, a way of keeping the moon's faster hours in proper step with the slower hours of home. It is one of the first times in history that humanity has had to ask, in earnest and out loud, what o'clock it is on another world. A clock left standing on the lunar surface would steadily drift ahead of every clock back on Earth, day after day after day, and that gentle drift must be accounted for in all the careful planning. The moon, it quietly turns out, keeps its own slightly quicker time. The very same will be true in its own particular measure for every single world that any traveller ever visits. A clock set upon the surface of Mars with its lesser gravity and its own swift yearly motion around the sun would keep its time at a rate subtly different from a clock back on the Earth. Neither wrong nor right, simply and only its own. The robotic explorers that already roam the red deserts of Mars run on their own Martian days, days a little longer than ours, and the teams who guide them from Earth have learned to live for a while on Mars time, waking and sleeping by a clock that slips a little later each day, drifting slowly out of step with the sun back home. And one day, when people themselves walk that rust-coloured ground, they will keep a calendar and a clock shaped by a different world entirely, their hours quietly their own. Every planet, every moon, every drifting outpost adrift in the empty dark carries its own particular pace of hours, set entirely by how fast it moves and how deeply its gravity runs. There is no master clock hanging anywhere over the solar system to which all the others must answer and bow. Each separate world keeps its own honest time, freely, and any traveller journeying between them must simply learn to translate carefully from one set of hours into another. Even the most distant human-made things carry this tiny signature quietly along with them, out into the dark. These two slender craft were sent out long ago to visit the great outer planets, and having done so, they simply kept going, climbing forever outward, until they crossed the invisible shore where the sun's wind gives way to the space between the stars. They are the most distant objects human hands have ever made, so far now that their faint signals travelling at the speed of light take many hours to reach us. The two probes that have travelled the very farthest from the Earth, launched many decades ago and now drifting on beyond the edge of the sun's own domain, have been moving for so long and so fast that their onboard clocks have slipped a small but measurable fraction behind the steady clocks back home. The amount is small, mere fractions of a second gathered slowly across many long years of silent flight. But it is undeniably there, accumulating in the cold and the dark, a faint relativistic memory of the long, long journey, woven now into machines so impossibly far away that their faint radio whispers take the better part of a full day just to reach us. To ever catch effects as delicate as these, humanity has had to build clocks of an almost incomprehensible steadiness. The very best atomic clocks now keep time so precisely that, had one of them been started running at the birth of the universe itself, nearly 14 billion years ago, it would not yet have gained or lost so much as a single second in all that time. That is the steadiness against which the faint bending of the hours must be weighed, and only a rhythm that unwavering could ever reveal so soft a thing. And the newest clocks of all are finer still, reaching out past even that astonishing standard. The most advanced optical clocks, which count the rapid shimmer of visible light rather than the slower steady hum of microwaves, are now so stable in their keeping that they would lose or gain only a single second across many, many times the entire present age of the universe. They are the most precise instruments ever built by any hand in all of history, and their staggering precision is exactly what allows them to feel the slowing of time across the height of a single small step. The finer the clock that is built, the more delicately it can sense the bending, and these new clocks are fine enough at last to hear time itself sloping downward across the width of a tabletop. A quiet subtlety hides itself inside all this precision, one that gently shapes how the whole wide world agrees upon the hour. The official length of 1 second is defined by the steady, faithful vibration of a particular atom, but because time runs at genuinely different rates at different heights, that definition only holds exactly true at one chosen reference level, near the surface of the sea. Lift the atom higher, and its seconds stretch out longer, lower it down, and they shrink. So the world's careful timekeepers must agree not only upon which atom to use for the measuring, but upon what precise height to imagine it sitting at while it does so. The very meaning of a second is anchored quietly to a place within the Earth's own gravity, a gentle reminder that even our most basic and humble unit of time has a home, a particular elevation it calls its own. Around that careful definition, the world keeps all its shared clocks in step through small and deliberate adjustments. Because the Earth's spin is very slightly irregular and gradually slowing over the long ages, the steady atomic seconds occasionally drift out of step with the actual turning of the planet itself, and so now and then a single extra second has been added in to bring them gently back into agreement. A leap second, slipped softly into the world's timekeeping so that the clocks and the wheeling sky do not slowly, imperceptibly part ways over the centuries. There was a time, not so very long ago, when the turning of the Earth itself was the one true clock, the standard against which all other timepieces were judged and corrected. Now that has reversed. The atom keeps the truer time, and it is the spinning planet that is found to wander, slowing by tiny irregular amounts as the tides drag against it and the seasons shift its weight about. The day is no longer the master of the second has become the master of the day. It is a small and graceful human accommodation to the deep fact that no two clocks anywhere, not even the spinning Earth and the humming atom, ever keep perfectly identical time. Even our calendars carry a faint, quiet memory of time's gentle refusal to flow at one single fixed rate. The bending of time can even be read directly in the behaviour of a single particle, split gently in two. In the most delicate experiments ever performed, physicists send one particle along two different paths at the very same instant and then carefully bring it back together again, and the particle carries within it, in its own faint interference pattern, a faithful record of just how much time passed along each separate route. If the two paths happen to differ even slightly, in their speed or in their height above the ground, the particle returns subtly changed, having counted up the difference in time between its own two simultaneous journeys. A single particle, in a very real sense, becomes its own private pair of twins, comparing the hours of two roads that it travelled both at once. Researchers have even begun to gently place clocks themselves into that same ghostly quantum state of being in two places at one time. The quantum world allows a tiny thing to exist in a blur of possibilities at once, not yet settled into any single one. A particle that is, in a real sense, in two places until the moment someone looks. In recent experiments, a small cloud of atoms acting together as a single clock has been carefully spread across two slightly different heights at the very same moment, so that, in the strange and lovely logic of the quantum world, the clock keeps time at two different rates simultaneously. The higher portion of the clock ages a fraction faster, the lower a fraction slower, and the two are not separate clocks but one single clock, smeared gently across both heights at once, ticking in two tempos that have not yet been forced to choose between themselves. It sits at the very frontier of what is understood, a place where the two greatest ideas in all of physics brush up against each other, and no one yet knows the full shape of what lies beyond. It is a quiet meeting of the universe's two greatest theories, the relativity that bends time with gravity, and the quantum mechanics that lets a single thing exist in many states at once, brought together at last within one shimmering and delicate experiment. A clock, held in two places, keeping two different times, both of them equally and fully real, right up until the moment it is finally read. It is worth pausing now as the night deepens softly around you on a particular feature of the motion-born slowing that seems almost like a paradox and yet turns out to be perfectly consistent. When two travellers drift past each other through the empty dark of space, each one of them sees the other's clock running slow, not one of them slow and one of them fast. Both of them, each one, sees the other as the slowed one. It sounds at first like a flat contradiction, but it truly is not, because while the two are simply passing by, never to meet again, there is no shared single moment in which to lay the two clocks down side by side and finally settle the matter between them. Each of them is entirely right within their own frame. The disagreement can only ever be resolved if they come back together once more, and coming back together always requires that at least one of the two of them must turn around. That single turning is the whole quiet secret of the famous twin story, and it dissolves the apparent contradiction entirely, completely. As long as the two travellers simply move apart from one another, the situation is perfectly symmetric, each one of them seeing the other's clock slowed, with no fact of the matter at all about who is truly aging the less. It is only when one of them turns and returns, feeling the firm push of that very turning, breaking the long, smooth, straight path through space, that the symmetry finally breaks and a real, lasting difference appears between them. The one who accelerated, who curved back homeward, is the one who has aged the less. Without that turning, there is no younger twin at all, only two travellers drifting ever apart, each one calmly and equally convinced that it is the other's clock that runs slow. Through all this endless bending and stretching of the hours, the universe guards one single thing with the most absolute care, and it is perhaps the most reassuring guarantee in all of physics. No matter how greatly time may slow, or how far space may contract, no signal can ever travel faster than light, and so the order of cause and effect can never once be scrambled or reversed. A cause always comes before its effect, for every observer, in every frame, no matter how quickly or in what direction they move. The bending of time is generous and strange and deep, but it is never once chaotic. It never, ever lets the future reach back to disturb the settled past. Whatever happens out in the world happens in an order that all observers, however much they may disagree about mere durations, will always in the end agree upon. The long story of the world is bent, yes, gently and everywhere, but it is never, ever broken. Around every single event there is a kind of shape that holds this great guarantee in place, a structure made up of all the paths that light itself could possibly take. From any given moment, light spreads outward into the future, and it could have arrived from the past along the very same kind of paths, together tracing out a great double cone reaching through space and through time. Everything that you could ever possibly affect lies inside the forward cone. Everything that could ever have reached out and affected you lies inside the cone stretching out behind. And beyond those two cones lie all the events forever out of reach, too far away for any beam of light to ever bridge the gap. Each moment of your whole life sits quietly at the meeting point of its own two cones, a single small lantern of influence shining in the dark, reaching only just as far and just as fast as light itself will ever allow. There is a quiet kindness folded into this shape too. It means that no distant catastrophe among the stars can reach out and touch you faster than the warning light of it could arrive, that the universe, however vast and strange, always announces itself at the unhurried pace of light, never sooner. Everything that could ever matter to you must travel to you along those paths, in good order, in due time, and so the night around you holds no sudden hidden reach, only the slow, honest arrival of light from everything there is. There is a particular and lasting peace to be found in the simple state of falling freely, and it touches the very heart of how gravity and time fit together. When you fall without any resistance at all, drifting, weightless, pulled along by nothing that you can feel in your body, you cannot sense gravity in the slightest. You feel as light and as free as if there were no pull anywhere in the whole universe. An astronaut adrift up in orbit is doing nothing more than falling endlessly around the curve of the Earth and feels no weight at all upon them. This is the surprising truth behind that floating ease seen in every picture from space. The crew are not beyond gravity's reach at all. Gravity up there is nearly as strong as it is on the ground. They are simply falling, all of them, and their whole craft together, forever curving around the planet and never striking it, and a thing that falls freely feels no weight. A dropped pen beside them hangs in the air not because gravity has let it go, but because it falls at exactly the same rate they do, the two of them descending together in an endless shared plunge around the world. And in that gentle state of free fall, time flows in its most natural and untroubled way, the body moving smoothly along the very grain of space-time itself. To fall freely is, in a deep sense, to follow the exact path the universe itself would choose, the gentlest, truest, most unforced line through all the bending of things. Across the small span of a single human body, the differences in gravity's pull are almost unimaginably gentle and faint. The pull on the crown of your head and the pull on the soles of your feet differ only by the very faintest trace, and the bending of time across the whole height of you is gentler still, a gradient so impossibly soft that no human sense could ever once detect it. You are, in the most literal way imaginable, spread thinly across a tiny range of slightly different times, your various parts each ticking along at very slightly different rates from one another. But the differences are so small, so exquisitely and impossibly fine, that you remain perfectly whole, one single seamless person, the faint internal disagreements of all your countless clocks far, far too small ever to pull you apart, or even to whisper the smallest hint of their quiet presence to you. Return for just a moment to the dense and brooding heart of the galaxy, where the great central mass holds its silent court, and consider gently what time does there in its near neighbourhood. Close to that vast and crushing object, The hours pass more heavily than they do far out in the calm, drifting suburbs of the Milky Way, where our own sun makes its long, unhurried rounds. A clock somehow placed near that centre would tick more slowly than every single clock among all the outer stars, lagging gently and forever behind the steady rhythm of the wider galaxy around it. The whole great spiral, in a sense, keeps within it a wide range of times, swifter out at its drifting edges, slower in near its heavy crowded centre. A single enormous wheel of stars turning patiently through a soft gradient of hours, the deep middle of it always running just a little behind the bright far rim. Around such massive objects, when matter gathers in and spirals slowly inward, it forms a great glowing disk, and the light streaming from that disk carries the clear marks of bent time upon it as it climbs away into the dark. Such a disk is one of the most beautiful structures in all the heavens, a vast flattened whirlpool of glowing gas, brighter and hotter toward the centre, spiralling slowly inward like water circling a drain, every ring of it turning at its own speed. The innermost edges of the disk sit deep down in the powerful gravity, where time runs slow and heavy, and so the light born there must climb up and out of that deep well to ever reach a distant watching eye, reddening steadily as it rises. Astronomers reading that light can sense, in its colours and in its flickering rhythms, just how steeply time slopes downward near the central mass. The disk becomes a kind of glowing dial, its bright spinning rings each keeping their own separate pace of hours, the inner one slowed, the outer one swifter, all of it written plainly in the colours of light that has climbed a very long way, up out of a deep and silent well of time, reddening with every metre it rises toward the watching dark. In the most distant reaches of the universe, the very brightest beacons of all carry these same effects across almost unthinkable gulfs of space. The blazing cores of certain far-off galaxies, lit by matter falling inward toward enormous central masses, shine so impossibly brilliantly that they can be seen clear across most of the visible universe. Their gathered light has travelled for billions upon billions of years to finally reach us, stretched by the long journey and by the patient expansion of space along the way, so that the very rhythms of their distant flickering arrive here slowed and deeply reddened. A single one of these blazing cores can pour out more light than all the hundreds of billions of stars in its galaxy combined. A beacon so bright it can be seen across nearly the whole reach of the observable universe. They are powered by matter falling inward toward a central mass beyond all imagining, heated to a fierce glow in its final spiral before it vanishes from view. They are violent and furious places, those bright cores, but from this immense and merciful distance they appear utterly silent, utterly still, mere points of ancient light, their fury softened entirely by the sheer scale of all the space and all the time lying between us and them. Distance itself turns even the wildest of fires into a single still point of light in the dark. The very oldest light of all reaches back nearly to the beginning of everything, and time has stretched it almost beyond all recognition, spread evenly across the entire sky, in every direction you could ever turn to look. There is a faint and gentle glow left over from when the whole universe was very, very young. A vast sea of light set free at the moment the cosmos first became clear and transparent, more than 13 billion years ago. When that light was first set free, it was a fierce orange glow, the colour of a sky on fire, pouring from a cosmos as hot as the surface of a star and filling every corner of it at once. There was no darkness anywhere then, no night, only that even radiance everywhere you might have looked. In all the long eons since that distant morning, the steady expansion of space has stretched that ancient light enormously, cooling it and lengthening its waves until it now glows only as the very faintest whisper of microwaves, far too cold and far too gentle for any human eye to ever see. Its temperature today is just a few degrees above the very bottom of the cold, the absolute zero where all motion ceases, a chill that fills the whole of space evenly, in every direction at once. The fire of the young universe has cooled, across 13 billion years of stretching into the faintest possible warmth, a soft uniform hush that bathes every star and every world and every sleeping body, including yours, this very moment, without your ever feeling it. It is the most stretched out light in all of existence, the most ancient message still arriving even now, a soft and uniform hum that quietly fills the whole of space, the cooled and patient echo of the universe's own first clear morning. That great stretching is the steady work of space itself, expanding, carrying all the galaxies steadily apart from one another and lengthening every single wave of light that crosses the slowly widening gulfs between them. The farther that any light has had to travel, the more the steady growth of space has drawn out its waves along the way, shifting its colour ever toward the red and slowing the apparent tempo of whatever distant thing first sent it forth. It is not that the galaxies are flying outward through space, like fragments hurled from a blast. It is space itself, the very distance between things, that is swelling everywhere at once, carrying the galaxies along the way raisins are carried apart in rising bread. A wave of light crossing that growing space is stretched along with it, drawn out longer and slower the farther it travels. In just this way, the expansion of the universe is itself a kind of time stretcher, working upon the very grandest scale of all, drawing out the rhythms of distant events as their old light crosses billions of years of swelling growing space. The cosmos does not only bend time with gravity and with motion, it also stretches time softly, patiently, simply by the act of quietly growing larger. To keep all of these countless differing clocks in some kind of order across the vast reaches of space, scientists have carefully agreed upon shared bookkeeping times, careful, abstract, agreed-upon standards that let missions all across the solar system coordinate with one another despite all the bending. More than 400 atomic clocks, scattered across dozens of countries and laboratories on every inhabited continent, are forever compared against one another, their readings gathered and averaged and woven into a single agreed-upon time for the whole planet. No one clock among them rules, each contributes its steady voice, and the chorus together keeps a beat more reliable than any single instrument could alone. Because they sit at different heights and in different gravities, each one runs at its own faint rate, so their keepers must correct for the bending of time before blending them, lifting every reading to a common reference level, as if all the clocks had been carried to the same shore. There is a master timescale woven together from the steady readings of many atomic clocks placed all around the world, and carefully adjusted for each of their differing heights, that serves now as the steady reference for all of civilization's most precise timekeeping. It is not the time kept by any single clock anywhere, but rather a kind of agreed-upon average, a common shared hour into which everyone can translate their own particular local time. Even amid the universe's deep refusal to ever keep one single time, humanity has gently built itself a shared rhythm to navigate the days by. For the wider solar system, there is an even grander shared clock, one imagined to tick steadily at the very centre of mass of all the sun and all the planets taken together, far from the gravity of any single world. The sun does not sit perfectly still while the planets wheel about it. It too swings in a small, slow circle, tugged this way and that by the gravity of its children, especially the great heavy worlds. The true fixed point of the solar system is not the centre of the sun at all, but a balance point among them all, and it is there, at that shared centre of mass, far from the strong gravity of any single body, that the steadiest clock of all is imagined to tick. Astronomers use this barycentric time as the calm, steady backdrop against which to track their spacecraft, and to predict the eclipses, and to chart the long, slow dance of the planets, translating each local clock carefully into that one common frame. It is a clock that no one could ever actually build or hold or set upon a shelf, existing only as a careful and shared agreement among minds, and yet it lets people scattered all across the earth speak together of distant cosmic events in a single shared language of time, a quiet triumph of patient cooperation over the universe's stubborn multitude of hours. And yet, beneath all of these shared and averaged and agreed upon times, the very deepest truth remains tender and personal and yours. The only time that is ever truly real for you is the time that your own body quietly keeps, the proper time, ticking faithfully along the single unrepeatable path of your own one life. Every shared standard, every carefully averaged clock is only ever a convenience, a way for many separate travellers to coordinate their plans. But none of them is the one true time, because there simply is no one true time anywhere to be found. There is only the honest count of seconds along each separate journey, and yours is yours and yours alone, kept faithfully by every cell and every slow heartbeat, measuring out the one single life you are actually truly living right now. This means that a humble old clock hanging upon a kitchen wall and the very finest atomic clock resting in a national laboratory are both, in their own separate frames, entirely and perfectly correct. There is something freeing in that thought. The old clock on the wall, ticking a little behind the radio's chime, is not failing at some single true time it ought to be keeping. There is no such single true time anywhere for it to fail. The simple wall clock may run a little fast or a little slow by the world's careful shared standards, but along its own small path through space and through time, it keeps perfectly honest time, its own true proper time, faithful to exactly where it sits and how it moves. There is no clock anywhere in the whole universe that is wrong in some grand absolute sense. There is only each separate clock, faithfully keeping the time of its own particular place. The great atomic standards and the quiet ticking kitchen clock are simply telling two different, and equally true, stories of the passing hours along their two different paths. This is the very reason that even the position a small phone reports already carries a relativistic correction folded within it, woven so deeply into the fabric of ordinary life that no one ever once notices it is there. The little device listens patiently to the clocks up in orbit, clocks that have been deliberately tuned in advance to account for the bending of time, and only because of that one hidden correction can it ever place you correctly upon a map. Every casual glance down at a location, every quiet confirmation of just where you happen to stand in the world has passed silently through the deep mathematics of bent and stretched time. There is a gentle wonder in that thought worth holding for a moment, that the deepest truths about time, the ones that took the greatest mind of an age to uncover, are not locked away in some distant observatory, but are at work in the most ordinary moments of an ordinary life, in finding a street, in meeting a friend, in coming home. The strangeness of relativity is not somewhere far away across the stars. It is already right here in your hand, already in your pocket, working quietly and unseen while you rest. Lift your gentle imagination once more, up to the great archive of the night sky, where time and distance are truly the same single thing, only seen from two different sides. The light from the nearest large galaxy to our own, the great faint spiral of Andromeda, set out across the dark some 2.5 million years ago, long, long before there were any people anywhere to look up and to wonder at it. It is the most distant thing the unaided human eye can reach, that pale oval glow, a whole separate island of 1 trillion stars, so far away that its light, racing toward us at the fastest speed the universe allows, has still spent ages upon ages on the road. So when you finally see that faint soft smudge of light on a clear and moonless night, you're seeing it not at all as it is right now, but only as it once was, when the very first stirrings of humanity were just beginning down here. The galaxy you glimpse is a portrait of a long-vanished moment. Whatever is truly happening within it tonight, new stars kindling, old ones guttering out, will not be visible from Earth for another epoch yet, long after everyone now living has become a whisper in the deep past. To look at Andromeda is to hold an ancient photograph up to the dark and call it the present. That gathered light has been travelling, patient and unhurried, across a whole ocean of empty space, carrying that one ancient moment forward through all the long ages to arrive at last within a single quiet upward glance. Closer to home, the very deepest places upon the earth keep the very slowest time of all by the faintest of all possible margins. At the very bottom of the deepest ocean trench, kilometres and kilometres down below the bright surface, a clock would sit a little nearer to the planet's heavy centre, a little deeper down in its gravity well, and so it would run the very merest trace slower than a clock kept up at sea level. The difference is so small as to be almost purely imaginary, far, far less than a single second across the entire vast age of the planet itself. But it is genuinely real. Down in the cold and the crushing dark of the deep sea, in the silent pressure of the great abyss, time creeps along just a whisper more slowly than it does up in the bright thin air above, faithful always to the very same rule that governs the distant stars. The strange creatures that drift through those lightless depths, the pale fish and the soft glowing jellies, are living, by the very faintest measure, a sliver behind the gulls wheeling far overhead, the whole ocean a gentle staircase of time, each layer slightly slower than the one above it, from the sunlit surface all the way down to the still black floor. The bending of time even lends a soft shape to the very largest question of all, the deep question of beginnings. The expansion of the universe, when it is carefully traced backward through the ages, points toward a distant time when absolutely everything was unimaginably hot and impossibly dense, nearly 14 billion years ago, and the deeper structure of space and of time itself grows strange and unfamiliar as it is followed back toward that very first horizon. There is no need at all to peer hard into it tonight. It is more than enough simply to rest gently in the quiet knowledge that time, as we know and live it, has a vast and gentle depth lying behind it, far longer than any single life, far longer than any single world. You sit safely atop an immense and quiet history of hours, resting securely on the near warm shore of an enormous span of time, and here is a true reassurance to carry down with you now, towards sleep, drawn out from all of this gentle bending. The simple fact that time runs at different rates in different places does not make your future fixed, or fated, or already written somewhere against you. It means only that time is personal, that your own hours are entirely your own, flowing along at their own true and proper rate, along your own particular path, neither racing on ahead of you nor falling behind you. No clock anywhere in the whole vast universe is hurrying you along. There is no master schedule pressing down upon you from above, no single great hour that you are somehow failing to keep. There is only your own gentle proper time, unfolding exactly as it ought to, at exactly the quiet pace your one life is truly meant to move. For in the very end, the bending of time takes nothing at all away from you. Every single moment that you live is counted faithfully and kept forever in the honest, unchanging record of your own path through the world, never erased, never lost, never once stolen away by the strange arithmetic of relativity. The slowing and the stretching of the hours do not steal your moments from you. They only reveal, gently, that those moments were always yours to begin with, always personal, always measured carefully along the one single road that you alone are travelling. Time is not a single great river, sweeping everything helplessly along at one fixed and indifferent pace. It is countless quiet streams, each one keeping its own private time, each one perfectly and equally true, and yours flows softly onward, gathering up its seconds one by one, all through this deep and restful night. So let the very last wonder settle down over you now, like a warm and weightless blanket drawn up to the chin. The universe does not keep one single clock. It holds within itself instead a great and boundless multitude of hours, the swift racing time of a falling particle, the slowed and heavy time at the very heart of a burning star, the faster lighter time upon a windswept mountaintop, the personal private time of every living thing that has ever drawn a single breath. There is no one universal now spreading out across the whole cosmos, no great bell tolling the very same instant for all of it together. There is this place, and the present moment you're breathing through, and the soft, countless presence of everything else there is, each one of them entirely real, each one of them perfectly true, each one faithfully keeping its own gentle hour out in the dark. And there is such a deep and lasting peace to be found resting in that. You do not have to keep the universe's time, because the universe quietly keeps none at all. You only ever have to rest in your own, this single breath, this single moment, this one gentle hour that belongs to no one in all the world but you. Every star scattered above you is keeping its own slightly different time, and so is every grain of sand beneath you, and so are you, here, now. And all of it, every bit of it, is exactly as it was always meant to be. The cosmos is in no hurry at all. It has been unfolding its many quiet hours for nearly 14 billion years already, and it will go on unfolding them long after this one night has faded softly away into the morning. And if you're still here, drifting, with the eyes already grown heavy, another quiet journey is already waiting there on the screen for you, ready whenever you are or never at all, asking nothing of you tonight. There is no need to choose, no need to reach, no need to do anything but rest. Let your thoughts grow slow now, like a clock sinking gently down into a deep well of gravity, each passing second stretching a little longer than the one before it. There is nothing left now to understand. There is nothing left at all to hold. The hours will keep themselves as they always have, with no help needed from you at all. You've done more than enough simply by being here, simply by breathing, simply by letting all the wonders move quietly through you and out again into the soft dark. The mind is quieting now. The body is growing heavy and warm and still. Somewhere high above you, a small clock on a satellite is running a few millionths of a second fast, and it does not need you to watch over it. Somewhere deep beneath you, the iron heart of the world is running a little slow, and it asks nothing of you either. All across the wide cosmos, the countless hours are keeping themselves, gently, faithfully, without any effort at all, exactly as they have always done. You are held now, safely, inside your own soft hour. Let it carry you. There is nowhere at all to be, and nothing to keep, and no time to keep it by. Just this one breath, just this gentle warmth, just the slow and certain rhythm of a single life, keeping its own true time, here in the quiet, where you're safe and held and home. Let the eyes stay closed, let the breath grow long, let the very last thought dissolve away like the oldest light of all, stretched gentle and cool and endless, fading softly down into the dark. And now 101 wonders are resting with you. Sleep now. Good night.